course of data structures. In the last session, we started with the introduction to the data structure and we saw how the memory is allocated statically versus dynamically. So with that background, we are going to discuss the first data structures in this video, that is arrays. Arrays is widely used data structures because it is simple to implement, simple to use for every programmer. So let's get started by looking at what is an array, how to declare the array and how to use it. The array is nothing but the collection of similar data items. For example, in C++, I can say, I want to store the employee IDs of 5 employees. So instead of declaring 5 different integer variables, you can declare or define an array. So here the syntax is int employee IDs. In the square bracket, you have to provide the size of the array. Means the number of elements you want to have in the array. Let's see now how the memory is allocated for the array. The memory for the array is allocated in a contiguous manner only. To explain it, let me take this analogy. Let's say you are a group of 5 friends and you all 5 friends decide to buy a row house. But you decide that we will buy the row houses only if 5 row houses are available in a contiguous manner. So I can say this is the array of 5 row houses I want to buy. Now let's say you go to some builder and ask, do you have the 5 row houses available in a contiguous manner? And let's say these are the availability of row houses. The green ones are available and the gray ones are sold out. So if you 5 friends wants to buy 5 row houses, you have to look for those 5 houses which are available in a contiguous manner. So I can see the first 2 houses are available, but the next one is not available. The third one is not available. So I cannot allocate these 2 houses to any of the friend. But definitely, here is the chunk of houses 1, 2, 3, 4, 5, 6. 6 houses are available in a row. And out of this, I allocate 5 row houses to each of the friend. So that's how the memory allocation for array elements happens. Considering this is one element of array and this is your memory location. So for all the elements in the array, you have to find, means the OS needs to find the contiguous memory is available and then only the allocation of memory can happen. If the contiguous memory is not available, then the allocation of memory will fail for that array. Let me show you with the help of C example. Let's say you define the array of 5 employee IDs. Assume that the size of one employee ID is 4 bytes. Means size of one integer is 4 bytes. And how many integers you have? 5 employee ID means 5 integers you have. Now here is my address space, that is logical address space. So when you define an array, the name of the array, that here the name of the array is employee IDs, EMP IDs. A constant pointer is declared internally. A constant means whose value cannot be changed. And employee ID is a pointer here, means it is going to hold the address. Now which address it is going to hold? It is going to hold the address of the first element of the array. Let's assume that this memory is allocated for the array starting with the address 23. So if the first element's address is 23 and element size is 4 bytes, then the address of the next element will be 27, the address of the third element will be 31, 35, and the last element will start with the address 39. So with the offset of 4, every element will be situated in the memory. And out of these 5 elements, whose address employee ID's pointer will hold, that is the address of the first element, that is 23 here. And with the help of this pointer, I can access all the elements of the array. So let's see how to access all the elements with respect to this constant pointer. So you have two ways of accessing the elements of array. One is with the help of the subscript and other is with the help of a pointer variable which you define. So the usage, the name of the array followed by the index of the element. For example, if you define the 5 employee IDs, you can say A0, A1, A2 up to A4. So I is called as the index of an element in the array. So you can simply say A of the element number. Whereas you can define a pointer or you can make use of the name of the array itself, which is also a pointer. Alright. So you can simply say the starting location plus which element you want. For example, if you want the first element itself, means 0th element, I can say. You have to say A plus 0 and value at that address you can access like that with the help of dereference operator. You can also say A plus 1, so it will point to the second element of the array. A plus 2, it will point to the third element of the array, and so on. It is easy to write with the help of subscript, so it is user friendly, programmer friendly, I can say. But eventually, this statement A of I, it is going to be converted into star of. Star means value at the address A plus I. So it is machine friendly basically. The name of the array is a constant pointer, but if you define your own pointer, you can change the value of the pointer as well. Adding some number to the pointer is allowed. Let's say A plus 1, A plus 2, you can do that if A is the name of the array. And here P plus 1 is also allowed. One of the difference between subscript and superscript is you cannot change the value of the constant pointer. As I showed in my previous diagram, you cannot modify the value of the constant pointer. And what is that constant pointer? The name of the array itself. So you cannot do A is equal to A plus 1 if A is the name of the array. But certainly, if P is a pointer, variable pointer, you can always change the value of a pointer. You can say P is equal to P plus 1 and then access the next element with the help of P. Let me show with the help of C example here how to access these elements. So the first method is when you define an integer array, let's say employee ID is 5, the first element can be accessed with employee ID is 0, employee ID is 1, 2, 3 and 4. So that's how you access the 5 elements with the help of the index varying from 0 to 4. You can also write a for loop for this. The second way is with the help of a constant pointer. Employee IDs itself is a constant pointer. So whether you call it as a employee IDs bracket 0 is equal to 10 or you write the statement as value at the address employee ID plus 0. These two statements are same statements or similar statements. Whereas with the help of constant pointer, I can say constant pointer is pointing to the first element. So with respect to first element, I want to access the second element. With respect to the first element, I want to access the third element. So you can add the offset to the first element's address and access that particular element. So to access the last element, I can say employee ID is plus 4 and value at that total address would be 50. That's how you can access means either you can modify the data at that address or read the data from that address. And the third way is the pointer. As I said, you can declare your own variable pointer. So along with employee ID is 5, which is array, I am defining a pointer here, p, and I am going to store the address of the first element of the array, that is employee ID 0, in the p. And once p refers to the first element, I can make use of this p to access the first element. This statement, value at p is equal to 10, is similar as this statement here, employee ID is 0, similar as employee ID is with square bracket 0. So all these three statements, this and this are same. Now with the help of p, I want to access the second element. So I can increment the value of p here. I can say p++, and then it will point to the next element of array. And now with the help of this p pointer again, you can access the second element, and so on. You can again do p++, it will point to the third element. You can access it. You can again increment the p. So as I said earlier also, you can make use of the for loop also to access all the elements. So here I have taken I is equal to 0 up to 4 less than 5, that is 4, and I++. So I have written the printf statement, element number %d, and address. I have also printed the address of every element here. I can specify, I can print the address with the help of %p or %u also. %u is unsigned integer. So I'll just print the decimal value of the address and the actual value of the element. So here is the element number, which is I, the first argument, and the address of the element, employee ID is plus I, and the value at that address. So that's how this for loop is going to print the element number, the address, and the value at that address. Let's look at the output of this program. So here is the element number I means 0 here, address, let us assume that it starts with 23, the value is 10. Element 1, value is 27, sorry, the address is 27, see the difference is 4, value is 20. Again, the next address is 31, 35 and 39. Now there are two ways you can declare an array, static array versus dynamic array. What is meaning of the static array? Static array means you as a programmer already knows the size of the array. So you simply say employee ID is 5 because I as a programmer knows the size of the array. Use the array elements and the memory allocated for these 5 elements will be freed out when this function returns. Why so? Because this is just a local variable. Alright. Whereas, how to define the array dynamically? Suppose that you as a programmer do not know how many employees are going to be there. For how many employees I want to allocate the memory. So number of employees itself is a variable here I have declared. So we will get the input from the user. You tell me how many employees you want to enter or you want to store in memory. I have written a scanf statement. So let us say at the time of execution, whoever is executing the program, that user gives the input as 10. It wants to store the employee IDs of 10 employees. But it is all decided at the runtime. Programmer do not know that. Now, first I have to define the pointer at which, you know that for doing the dynamic memory allocation, first we need to define the pointer variable. And with the help of a malloc function, I say that I want to allocate the memory for 10 employees, whatever be the value of number of employees. I am just assuming 10. 10 into size of each integer. Assume that the size of integer is 4 bytes. So if user gives the input as 10, 10 into 4 will be 40. 40 bytes will be allocated and the address of the first byte will be returned and stored in the employee IDs. If the user gives the input as, let us say 50 employees, then 50 into 4, 200 bytes will be allocated by the malloc function at runtime and the address of the first byte will be returned. And with the help of this address now, I can access all the elements of the array with the help of this pointer. And once I am done using this array elements, I can free the entire memory that is allocated with the help of the free function. I have explained the malloc, calloc and the free function in my previous video also. So that's how this is the static array allocation versus dynamic array allocation. Let's learn the structures now. So along with the employee ID, let's say you want to store the other information of the employee, such as if you want to store the gender of the employees, the age of the employees. How can you do that? You have defined the array of employee IDs, let's say 5 employee IDs. So the question is, will you define the array for gender also? Will you define the array for storing the age also? So if you want to store the 5 attributes of an employee, you will end up in defining 5 arrays for each of the attribute. So there is a solution for that. The simple technique is use the structures. Now what is a structure? Structure is the user defined data type. For example, integer is a inbuilt data type. Float, char, these are all the inbuilt data type in C or C++. There are others also. Likewise, you can define your own data structure with the help of this structure concept. The structure is nothing but the collection of different data types. Let me explain with the help of the C++ example here. So here I am defining the structure employee. In the C++, you have to give the keyword called as struct keyword. So with the help of struct keyword followed by your own name of the data type. Here my own name of the data type is employee. Opening curly bracket and closing curly bracket followed by the semicolon. So I am going to define this structure in which I am going to define 3 data variables, 3 different variables called as integer employee ID, character gender, a single character gender to store whether it is male or female, M or F, and the third variable is the age, which I have taken as a float. So here the employee structure is a collection of 3 different variables, integer, char and float variable. Now once you define this structure employee, you can define the variable of that data structure employee, the data type employee, sorry. So let me write the main function here, and in the main function I am going to define the E1 as the variable of which data type? Employee data type. So the simple syntax is employee E1. If you want to define the employee E2, you can say employee E2, employee E3, and etc. So when I say employee E1, let's look at how the memory is allocated for the employee E1 now. So let me take this logical address space. When the program is executed, this is my address space, and somewhere in the memory, somewhere in the logical address space, the memory for E1 will be allocated. Now consider that an integer size is 2 bytes, a character size is 1 byte, and a float size is 4 byte. So what is the total size of this structure I have defined? Which is the 7 bytes. So if you define a variable of employee, 7 bytes are going to be allocated by the operating system. Now, what is the arrangement of these variables in these 7 bytes? Assume that these 7 bytes starts with the address 46. So right from 46, 47, 48, etc. So 7 addresses starting with the 46 will be reserved or will be allocated for the employee one. Now, in these 7 bytes, what is the arrangement of these variables? So, in the same sequence in which the programmer has defined the structure, employee ID, then gender, and then age. So, in the same sequence, the memory is going to be allocated within these 7 bytes. Oh, alright. So, first employee ID is of integer, and integer take 2 bytes. So, 46 and 47, these two addresses constitute the first variable employee ID. Next address is 48. Character is of 1 byte. So only at the address of 48, it will be the gender information stored. And 49, 50, 51 and 52, the 4 bytes are reserved or allocated for the variable age. So in short, the sequence in which you have defined the variables in the structure, in the same sequence, the memory is also going to be allocated. And these 7 bytes constitute your one variable of employee, that is E1 here. Now how to access these variables inside the E1? So here is the method for that. We say E1 dot employee ID is equal to 10. When you do that, the 10 is stored here. When you say E1 dot gender is equal to M, the character M is going to store here, and E1 dot age, the third variable, is going to store at its place. So that's how the structure variable, the variable of the structure, your own defined data type, looks like in memory. Now this is about the one employee. Now how to define the array of the employee? Let's look at that. So again, let me show. Here is the structure employee, same structure, and now with the help of this array, which is defined as employee emp5, you see, defining the array of structure is very similar to defining the array of inbuilt data type also. Earlier we said that int employee ID is 5. Int was the inbuilt data type. Now here employee is your own data type, user defined data type followed by the name of the array and followed by, in the bracket, the number of elements you want to allocate of that data type. So with this, memory for the 5 employees will be allocated. Let's look at the memory. So here is the again logical address space, the memory of the program, and let's assume that the array starts with the logical address 55. Alright, and one employee is going to take 7 bytes. So 55 plus 7, that is 62. So the next employee is going to start with the address 62. Again, the third employee is going to start in memory at the address 62 plus 7, that is 69, and so on. So with the offset of 7 bytes, I have each employee stored. That's how the array of the user defined data type structure is represented in the memory. Now accessing the elements within the elements is very simple. You have to just say employee 0 dot employee ID is equal to 10. 10 will be stored in the first employee ID's employee ID. Employee ID 0 dot gender, gender will be stored in the first employee, and so on. Now let me show more about how to traverse these elements of the array of structure. So one way I have already shown, employee 0 dot employee ID 10, employee ID 0 dot gender. That way you can just give the index employee ID 1 dot employee ID, employee 1 dot gender, and so on. So if you have 5 employees, you can say employee 4, that is the last employee, 0 to 4. Employee 4 dot employee ID is equal to 40 or something like that. So this is with respect to the name of the array itself. Now you can traverse these all elements of array with the help of a pointer also. So let me define a pointer of data type employee. So I can say employee star p. Earlier what you said? Int star p, isn't it? But here the pointer is going to point to a data structure. And what is a data structure? Is a complete bundle of 7 bytes, means employee ID, gender, and age. That constitutes your one variable. So you have to define the pointer of type employee is equal to, I have initialized this pointer with the address of the first employee in the array, that is employee 0. Alright, and now with the help of this pointer, you can access the employee ID, gender, and age like this. You have to give the arrow, hyphen, and the greater than operator, means arrow. So p arrow employee ID is equal to 10. So with the help of a pointer, that's how you access the elements or variables within the structure. Now I want to access the second element of the array, second employee of the array. So just increment your pointer by 1. Now it will refer to the next element in the array. And next element in the array is situated after 7 bytes. Alright. So with the help of this p is equal to p plus 1, now p is pointing to the second element of the array, that is second employee. Now again with the help of this p, you can say p arrow employee ID is equal to 20. So this statement here on the left hand side, like employee ID 1 dot employee ID 20 is equal to 20, you access with the help of the name of the array, or you access with the help of a pointer itself. You have to be a little bit cautious about accessing the array elements or modifying the array elements. Let's see what precautions you need to take. Let's first see what problems you may face if you try to modify or write the array elements. Let me take this program. I have defined the array of 5 employee IDs. It's just an array of integers, let's say, and one other variable, let's say x is equal to 50. So one array and one variable initialized to 50. Let me show it in memory. This is my array. Considering the size of one integer is 4 bytes, 5 into 4 is 20. So these are the total 20 addresses. Alright. So this is the employee ID 0, employee ID 1, 2, 3 and 4. And let's assume that after these 5 elements of array, the memory is allocated for the variable x, in which what value is stored? As of now, the value 50 is stored. Now what I am going to do, I want to write a program to initialize all the elements of array to 0. Let's write that for loop now. So I write a for loop, integer I starting with 0, I less than 100. Now I know that the array size is 5 only. But let's say you as a programmer, you as a human being have done the unintentional mistake here. It can be intentional mistake also. Alright. So let's say whether it's intentional mistake or unintentional mistake, you are going to traverse the array from 0 to 99. But actually, how many elements are there in the array? Simply 5. Only 5. But let's see what this program will do to your memory. So when I do that, when I value will be 0, employee ID 0 is equal to 0, first element will be initialized to 0. Second element, third, fourth and fifth. So up to 4, up to I value is equal to 4, it will work or behave as expected. Alright. But the moment I value crosses 4, it will become 5. And employee ID 5 means it is going to refer to the next address, that is 43. And it is going to overwrite the value of 50 and it will become 0. Further also, I value will become 6 and value at the next memory location will also become 0 and so on. So, because of this mistake, I have initialized all elements to 0, but I have also overwritten my other variables values. You can try this program in C++, and after this for loop, I have printed the value of x. Now tell me, if I have not modified the value of x after initialization, what is the expected value to be printed by this printf statement? 50 only. But you will observe that the 50 will not be printed by this printf statement. It will print 0. Alright. This program may behave differently when you execute in your machine, because it all depends on what is the placement of this variable x. Is it placed below the array or is it placed above the array? You as a programmer do not know that. Alright. So if it is just placed below the array and if you overflow the array writing, then definitely your variables are going to be affected. The second precaution you have to take is, while defining the array size, you have to think that if the total contiguous memory required for the allocation of the array is not available, the memory allocation is going to fail. Alright. So that point you always keep in mind. If you define a very huge array, an array of 1 lakh employee IDs, it may fail sometime. because that much contiguous space may not be available at the time of memory allocation. So that's the second precaution as a programmer you have to take. That's how we complete the basics of arrays, that is one-dimensional arrays. In the next video, I am going to start with the two-dimensional arrays. Thank you for watching the video. If you have any questions or comments, feel free to put in the comment box.